The problem statement for 4.5 is the barrel length of a 45 caliber pistol is 13 centimeters. The muzzle velocity and mass of the fired bullet are 260 meters per second and 16 grams respectively. Assume that the force is nearly constant and determine the acceleration and the force on the bullet. Here's the picture where I've shown the chamber length as x. That's the distance that the bullet will travel. It's going to accelerate to the right and have a final velocity, which is equal to the muzzle velocity. Free body diagram, very simple. Just here's a mass and there's the force on it. And I've repeated the acceleration here going to the right. That's not required, but I usually like to do that with the free body diagram. Now we're given the length of the chamber, the muzzle velocity, and the mass that I've converted here to kilograms. The unknown is the force and the acceleration of the bullet. And the theory is, well, the only force on this, the net force, is F, which we're looking for, and that equals the mass times the acceleration of the bullet. We need the kinematical equation that relates the final velocity to the initial velocity, which is 0, and the distance that the particle moves and the acceleration. In our solution, if we solve this equation for A, we get this expression right here. But I don't want to, at this point, plug in the numbers. I want to go ahead and algebraically solve for the force. The reason I do that, most likely on this, if I assign this problem as an exam problem, I probably won't ask for the acceleration. I'll just simply ask for the force. And you would want to write that out algebraically. Now, when you work the problem in class, most students, if we did this in class, most students would solve for A and then numerically plug it in here. But I want you to get F symbolically. So once you've substituted for the acceleration up here, then you get this expression. And then when you put in your numbers, you get the force is 14.16 kilonewtons. Now go back to, here's how you'd find the acceleration, which most students would do in a problem assignment. They would just plug in the values for A here and solve, and you get 2.60 times 10 to the 5th meters per second squared.